Hello everybody. Today we're going to be talking about periodic trends. This is section 9.9 of your textbook. If you haven't figured this out by now, the periodic table is filled with patterns. In fact, the word periodic means that there are trends or repeating patterns. Now, there are two types of patterns. There are patterns that occur when you go from left to right along a period. These are known as periodic trends. If you recall, there are 7 periods, and you'll notice that certain properties do follow patterns. However, there's also patterns that occur when you're going up down along a group, and these are obviously called group trends. So what we're going to study to start off our trends is going to be a concept known as atomic radius. Atomic radius can be defined easily as the size of an atom. Now, what I'm going to do here is I'm going to show you, if you look at, let's go back here for a minute. If you look at an atom here, let me draw one out here. Let's say this is the nucleus, okay? And here, let's say this is the outer electron energy level. Let's say this was hydrogen, which is diatomic. And here you have a second hydrogen right next to it. The technical definition is that it's defined as half the distance from one nucleus to the other. Now, if you notice, half the distance from one nucleus to the other would just be this part here, this red part. So when you think about it, the atomic radius basically is from the center of the atom to the outermost energy level, kind of like the radius of a circle. Okay, in fact, that's what we're looking at here. It basically defines the size of an atom. Now remember, atoms are tiny, so the appropriate unit that we're going to use is going to be nanometers. Atoms can also be measured in picometers, okay? And again, that's because they are very small. Now, I'm going to show you here what the trends are, and then we're going to discuss why they follow these patterns. According to the patterns, if you are going along a period, which means from left to right, notice it says down here that atoms actually get smaller as you're going from left to right. When you're going up down, in other words, along a group, it says that atoms are getting larger. Now, there are reasons for this, and I don't just want you to know the pattern, I also want you to know why they get smaller or bigger. If you look here, we have here from your book, you can see that as you're going down, you can see the atoms getting bigger. The atomic radiuses are increasing. And if you look carefully as you're going across a period, the atoms are actually decreasing in size. So here's what we're going to do. Let's explain each scenario. Okay? Let's take this group here, okay, which are the alkali metals. Although hydrogen is not technically an alkali metal, it's part of group 1. So let's take a look at this so you can see the explanation as to why atoms get bigger. If you have hydrogen, hydrogen has just one energy level. So the radius is basically from here to here. Okay? Underneath hydrogen, you have lithium. Lithium has 2 energy levels. So let's do this. Let's put the nucleus. First energy level, second energy level. And you'll notice that because there's 2 energy levels, the atom is bigger. Okay? If we continue to do this, here's sodium. Sodium has 3 energy levels, so you go 1, 2, and 3, and notice that the atom gets even bigger. Let's do one more. Let's throw potassium in here, and this keeps going all the way down to francium. So here you go, first energy level, second, third, and then you got the fourth. And you'll notice that as you go down a group, the atoms get larger. So there are 2 things going on here, okay? Basically, as you add more electrons, you're filling in more energy levels, so the atoms tend to get larger in size. And that's the general pattern that you see going up, down a periodic table. All right? Now, the one that's a little bit more difficult to explain is going to be the pattern along a group. All right? Let's take a look at this. We're going to erase this here for a moment, and we're going to pick group 2 I'm sorry, not group 2, period 2 of the periodic table. And we'll start with, let's say, lithium. Okay, if you notice, the atomic number of lithium is 3. Then beryllium will be the next one, and that one has an atomic number of 4. Then we go to boron, which is number 5. Then carbon, number 6. Then we go to nitrogen, which is number 7. And we can keep going here all the way to neon. I'll stop here at oxygen because you'll see what's happening. I'm going to draw the atoms. So all of these guys are in the second period, which means they all have 2 energy levels. So lithium would have, here's the first energy level, and here is the second energy level for lithium. The atomic radius would be this distance here. Now beryllium also has 2 energy levels. Okay, so let me draw this here, and we'll do this, and let me go ahead and draw beryllium over here. Okay, then boron also, same thing, and you're going to see something that I'm going to do here. As I draw them, and this one's boron over here, and I'm going to draw carbon. I want you to notice that purposely I am making the atoms get smaller and smaller. Okay, because what happens is, as you go to the right, they're going to decrease in size. Now there's an explanation for this. The term that we're going to use to describe this is called effective nuclear charge. Okay, and I'm going to explain what that is. Effective nuclear charge. As you go from left to right, notice that the number of protons increases. That's the atomic number. This one has 3 protons. Okay, also it has 3 electrons. This one has 4. This one has 5. So notice that the effective nuclear charge, which is essentially the number of protons in the nucleus, notice how that number begins to increase. Okay, so what does that have to do with influencing the size of the element? Well, if you think about it, the protons are found in the center here, in the nucleus. Okay, the more protons that are in the nucleus, the better that they pull. Now remember what they're pulling. Protons attract electrons. They're opposites in charge. So the more protons that are inside the nucleus, the better that they pull the electrons inward. So notice the electrons would get pulled inward more. So if you look at oxygen all the way on the right here, oxygen has 8 protons compared to lithium, which only has 3 protons. 8 protons pulls much more effectively than 3. So what I'm trying to say is this. The more protons that are in the nucleus, the more they pull the electrons inward. Now notice how I drew arrows pointing in. If those electrons, okay, are being pulled closer towards the middle, notice how that affects the size of the atom. And that's exactly what happens as you go from left to right. As the number of protons increases, which is called the effective nuclear charge, the higher number of protons pulls the electrons in more tightly. It pulls it more towards the center. And when you pull the electrons more towards the middle, it actually reduces the overall size of the atom. And that is the reason why atoms get smaller as you go from left to right. Okay, so we've seen 2 trends here. Okay, so atoms get bigger, okay, as you go up, down, okay, and let me show you here real quick. Notice atoms get bigger as you go down, and they get smaller as you go across. Now, this picture is also in your textbook, and these atoms are measured in nanometers, okay? And the transition metals were left out for simplicity. Now, you will notice that this is a general pattern. There are some exceptions, okay? Generally, they get smaller as you go to the right, but if you look carefully, you'll find some exceptions here and there, okay? There's always exceptions to all of our chemistry rules, but we care about is the normal general pattern, and that is they get bigger going down and they get smaller going across. But do keep in mind that there are some exceptions to the rule. You could see right over here, germanium is not much, but it's slightly bigger than gallium, okay? And you'll see some other exceptions, okay? As you go along, you'll see here, antimony is slightly bigger than tin, which doesn't follow the normal pattern. But generally, they do get smaller as you go across, okay? Now, let's take a look at one more thing here. We're going to go over right over here. And there's the other thing that I wanted to explain to you is something called ionic radius, okay? If you recall, an ion is a charged atom. And there are two ways that you can become an ion, either by losing electrons or by gaining electrons. And depending on what you do, the atom will compensate by either getting larger or smaller. So the first thing I'm going to show you is what is the result of an atom when it loses electrons. In other words, when it becomes positively charged. Remember that when you lose electrons, you are known as a cation. Now, according to this, you'll notice that when an atom loses electrons, okay, there's a decrease in the size of the atom. There's a decrease in radius. And the example that I'm going to demonstrate with you is magnesium. Okay, if you look at magnesium here, magnesium, being an alkaline earth metal, wants to lose 2 electrons. So let me demonstrate this to you with some proof. So if I were to draw magnesium, magnesium has the first energy level, here's the second energy level, and here is the third energy level. And it has 2 valence electrons here. This is magnesium when it's a normal atom. The distance from the nucleus to this outermost energy level, that would be the atomic radius. Now what happens is magnesium wants to lose 2 electrons. It wants to go to Mg plus 2. Now in order to do that, what's going to happen is this is going to lose those 2 electrons, and therefore this energy level will be empty. So as a result, look what happens to the size of magnesium. It used to have 3 energy levels, but when it loses this outer energy level here, the outer shell, it completely gets reduced in size, because now the distance is from here to the last occupied energy level. The one that used to be out here is no longer there. When an atom either gains or loses electrons and becomes an ion, it acquires a new distance. Notice how with cations, the distance gets smaller as a result of losing 2 electrons. We refer to this new distance as the ionic radius. Okay, and in general, cations, okay, what they do is they lose electrons. So cations, as a result of losing electrons, they're going to get smaller. And here's the evidence. If you look at real data, magnesium has a radius of 0.136 nanometers. After magnesium loses those 2 electrons, it significantly gets reduced in size, and it goes to 0.065 nanometers. Okay? So what happens if the atom is gaining electrons? Well, the opposite is going to be true. When an atom gains electrons, it will become negatively charged. It will be known as an anion, and there will be an increase in the radius. I'm going to show you this also using another example. I'm going to use nitrogen. Okay? If you look at nitrogen, nitrogen has 2 energy levels. It's in the second period, so it has 2 here, and then it has 5 valence electrons. Let's put here 1, 2, 3, 4, and 5. Now, nitrogen wants to gain 3 electrons and become -3. In order to gain 3 electrons, look what happens, how it affects the size of the atom. Okay? So every time an electron enters, the existing electrons, you know what they're going to do? They're going to scatter. They're going to space themselves out a little bit. They're going to move far apart to give this guy room to enter. Now, with nitrogen's case, not only is one going to enter, you're going to have a second one wanting to come in and a third. Okay? So what happens is the 5 atoms or the 5 electrons that were already in there, they're going to space themselves out to make room for these 3 electrons that are trying to enter. And what happens is by spacing themselves out, what the atom's going to do is it's going to plump up. Here's the original. Instead of it being over here, as you can see in my drawing, it's going to plump up and it's going to increase in size. So it's going to have a new radius known as the Ionic Radius. And the reason it increases is because the existing electrons, okay, and I'm drawing them now, have spaced themselves out to give room to those that entered. So I put here 1, 2, 3, 4, 5, 6, 7, and 8. And now this new ion, the nitride ion, has 8 electrons. And notice that in order to receive those electrons, the 5 valence that were there before, they scattered, they spaced themselves out, and in order to do that, the atom gets bigger in size. Here's the evidence. If you look at nitrogen when it's neutral, it has an atomic radius of 0.070 nanometers. After nitrogen gains those 3 electrons, it plumps up and it becomes 0.171 nanometers, so it gets significantly larger. Okay? Now, the good news is that for periodic trends, atomic radius and ionic radius follow the exact same pattern. Okay? And that is that it doesn't matter if you're talking atomic radius or ionic radius. When you're going from left to right, okay, the size of the atom, whether atomic radius or ionic radius, the atoms will get smaller, or the ions will get smaller. So they follow the same periodic trend. As far as the group trend, the same thing happens. As you know, going up, down, atoms plump up. They get bigger because there's more energy levels. So as you go down a group, whether it's atomic radius or ionic radius, the atoms will increase in size. All right? So let's wrap this up. Let me show you an example here. You might be asked, okay, which atom will be bigger if it's Fe or Fe plus 2? Let me give you a moment to think about that. I would like you to tell me which one is larger. The correct answer is going to be Fe is larger because Fe plus 2 lost 2 electrons, and anytime you're losing electrons, they're getting smaller. The same could be said to compare, let's say, Fe plus 2 with Fe plus 3. If you recall, iron can either be plus 2 or plus 3. Well, here you lost 2 electrons, here you lost 3. Which one do you think is bigger? The correct answer will be the Fe plus 2 would be bigger than the Fe plus 3. Here's a general rule. The more you lose, the smaller the atom gets. Here you lost 3 electrons, whereas here you lost only 2. Now, both of these are ions, so both of them are smaller than the original atom because they lost electrons, but the Fe plus 3 will be smaller than the Fe plus 2. So the general rule is the more you lose, the smaller the atom gets. Okay? And conversely, if you're gaining electrons, the more you gain, okay, the larger the atom gets. So this is our first trend in a sequence of periodic trends. So what we covered today was a trend called atomic radius, and we also saw the connection to ionic radius, and as you saw, they both follow the exact same pattern. Okay?